Hi everybody. In this video I will be explaining fractional and negative indices. In one of the previous videos I explained fractional indices specifically. In this video we're going to combine them with negative indices. I handed you guys exercise 4 in class and I'm going to go through these 25 questions. Right, so first of all what you need to remember is the basic rule of negative indices. When we have a negative indice, it becomes a positive indice in the denominator to the power of 1, right? And obviously then if we have a negative, let's say to the power of negative a in the denominator, it becomes a x to the power of a in the numerator. Right, so if we have a look at question 1, 3 to the power of negative 2 will become 1 over 3 to the power of positive 2 instead of the negative, and that gives us 1 over 9. So for question 1, the answer is 1 over 9. For number 2, the question is 2 to the power of negative minus 3, so it becomes 1 over 2 to the power of positive 3, which equals to 1 over 8. So number 2 is 1 over 8. For number 3, it is simply 1 over 4 to the power of 1, which is 1 over 4. We don't need to write the 1. So that one is a quarter. Right. For number 4, I'm going to write out the whole thing here so that you can exactly see what is going on. Remember BIDMAS, always try to do this part first. Now, you have a choice. You can either do this, 1 to the power of 3 to the power of positive 2, all to the power of negative 1, and that will give you, that means that you have to flip the whole fraction on the inside of the bracket, which will give you 3 to the power of 2 over 1, which is just simply 9. So you can either do this, or what you can do is, this is the raising of a power. And we know that when we raise a power, it is x to the power of a. This is the law, right? If we raise a power to another power, we simply multiply the powers with one another. So what we can also do is simply say 3 to the power of negative 2 times negative 1. And a negative gives us a positive, and 2 times 1 is 2, which equals 9. But the answer in both of these equate to 9. So for number 4, the answer is 9. Right, let me just make a little bit of space here for us. Good. Now for number 5, we've got 3 to the power of negative 2 divided by 3 to the power of negative 1. Now whenever we see a negative 1 in the denominator, we know that it's going to become a positive in the numerator. So all we do is we flip this whole fraction. The negative 2 becomes a positive 2 in the denominator, and the negative 1 in the denominator becomes a positive in the numerator. And then we can either cancel it out, or we can say 3 over 9, and we can simplify that to 1 over 3. Right, so the answer for number 5 is 1 over 3. Right, for number 6, we've got 5 to the power of 0. Anything to the power of 0 is always equal to 1. Always. Right, we've got the same one here, where we've got a half raised to the power of negative 1. And because it's simply a negative 1, we're going to flip everything inside the fraction 2 over 1 to the power of 1. And that's how we get rid of the negative. And that means that we simply left with 2, because 2 to the power of 1 is 2, and 2 over 1 is 2 in any case. Right, so for number 7 it's simply 2. The same for number 8, where we've got 3 over 4 raised to the power of negative 1. First we sort out the negative, and that means that we flip everything on the inside of the bracket, and that's raised to the power of 1. 4 to the power of 1 is 4, 3 to the power of 1 is 3. So the answer, 4 over 3. Right. For number 9, we've got a third raised to the power of negative 4. This means that we first need to get rid of the negative. We simply flip whatever is inside the bracket to 3 over 1 raised to the power of 4. Now, 3 raised to the power of 4 over 1 raised to the power of 4. 3 raised to the power of 4 is 81, and 1 to the power of 4 is 1. So the answer is simply 81. Right, and that brings us to number 10. Number 10 is 2 over 3 raised to a negative 3. Again, get rid of the negative by flipping everything on the inside of the bracket. So 3 over 2 to the power of 3, which means 3 to the power of 3 over 2 to the power of 3. 3 cubed is 27, and 2 cubed is 8. So your answer for number 10, 27 over 8. For number 11, we've got 5 over 3 raised to the power of negative 2. That means that we flip everything inside the bracket to get rid of the negative power. And now we simply remove the bracket. So 3 squared over 5 squared. 3 squared is 9, 5 squared is 25. So we've got for number 11, 9 over 25. Right, that brings us to number 12. Number 12 is 8 to the power of negative a third. Now this is where we combine a negative indice with a fractional indice. I always recommend do one step at a time. Do not try to do everything at once. So first of all, get rid of the negative. This means that we're going to have 1 over 8 to the power of a third. Please do not make the mistake and think that it's just 8 to the power of 3. It's still 8 to the power of a third. We didn't do anything to the fractional indice. We only removed the negative. And now we can remove the fraction by saying that this is now a cube root of 8, and the cube root of 8 is 2. So the power 8 to the power of minus a third is equal to 1 over 2, or a half. Right, for number 13, we've got 25 to the power of negative a half. Same thing. First, get rid of the negative by writing it as 1 over 25 to the power of a half. Again, it's not to the power of 2, it's to the power of a half. You cannot simply change a half to a 2 in the denominator. You only removed the negative. Right, now we can remove the half by saying it's the square root of 25, and the square root of 25 is 5. So your answer is 1 over 5. Okay, for number 14, we've got 16 to the power of minus 3 over 4. First of all, we remove the negative. So we've got 1 over 16 to the power of 3 over 4. Now we can go and we can remove the fraction. So it's going to be 1 over, remember the 4 goes on the outside, so it's right over there, and 16 to the power of 3 stays on the inside of this bracket. Now, when we enter this into our calculators, when we take the fourth root of 16 cubed, we get a very nice answer of 8. So our answer to number 14 is 1 over 8. Right, moving on to number 15. We've got 1 to the power of minus 3 over 2. Now, whenever you see a 1 as the base number, this whole part can be disregarded, because 1 to the power of anything is always just 1. Because it doesn't matter how many times you multiply 1 by itself, the answer is still only 1. So your answer for number 15 is a simple 1. Right, you could have worked it out by saying 1 over 1 to the power of 3 over 2, and then you take the square root of 1 to the power of 3 all underneath that bracket, and it's still only going to give you 1 over 1. So the answer will always just be 1. 1 to the power of anything stays 1. Right, so moving on to number 16. We've got a quarter raised to the power of a half, to negative a half, sorry. And first of all, get rid of the negative 1. We get rid of the negative 1 by flipping the fraction on the inside. And I'm saying flipping the fraction, but what we are in fact doing is taking that positive integer and making it a negative on this side and vice versa. Right, so we are simply keeping the indices on the inside positive by just flipping the fraction. Right, and now since we only have a 4 to the power of a half, right, we take the square root of 4 and the answer is a beautiful 2. Right, moving on to number 17. Just make some writing space there. Moving on to number 17, we've got 1 over 8 raised to the power of negative 2 over 3. First of all, get rid of the negative indice. We get rid of the negative indice by flipping the fraction inside the bracket. And we're still left with fraction 2 over 3 as a power. Now we can remove the fractional indice by saying it's the cube root of 8 square. Remember, 8 over 1 is simply 8. That 3 at the bottom becomes your cube root, and the 2 at the top in the numerator goes there. So we've got the cube root of 64, and the cube root of 64 is 4. Right, so number 17 is 4. For number 18, we've got 4 over 9 to the power of negative a half. Get rid of the negative 1 first by flipping the fraction. Now we've got 9 over 4 to the power of a half. And now we take the square root of 9 over 4. And that's how we get rid of the fractional indice. This means exactly the same as the square root of 9 over the square root of 4. Excuse me. And that leads to 3 over 2. So the answer for number 18 is 3 over 2. Right. Moving on to number 19. Number 19 gives us a combination of a lot of indice laws. So I'm going to write it out here just to make it easy. 4 to the power of negative 3 times 4 to the power of negative 1 all over 4 to the power of negative 4. Right. Now, my first step would be to get rid of all the negative indices. Well, if it's negative at the bottom, it's going to be positive at the top. So I'm taking this one at the bottom and I'm moving it into the numerator. Then I'm taking this 4 to the power of minus 3 and I'm making it a positive in the denominator. And I'm doing the same with the negative 1. I'm moving it to the bottom there. Now I'm applying my laws of indices, the basic laws of indices. That one stays the same. If I multiply two base numbers that are the same, I add the indices. So I'm going to get 4 to the power of 4 because 3 plus 1 equals 4. Now I can see that they are exactly the same. But if I wanted to apply the law, it's going to be 4 to the power of 4 minus 4. Because when we divide the same base number, we actually subtract the indices from one another. And 4 minus 4 is 0. And anything to the power of 0 gives us 1. Right. We could have seen this. This step is not necessary. You could see if the numerator and the denominator is the same, the answer will be 1. Right. So number 19 is a 1. For number 20, we've got 27 to the power of negative a third times 9 to the power of 3 over 2. Okay, so there's many ways in which you can do this one. I would suggest simply simplifying the indices first. So in this instance, I would turn this 27 into a third, get rid of the negative indice, and for this one, I would start by just simplifying it like that. Right, now I can see that 1 over, getting rid of the fraction, is the third root or the cube root of 27 times the square root, and 9 times 9 times 9 gives us 729. Right, I'm just going to carry on here. This would equate then to 1 over the cube root of 27 is 3, so it's 1 over 3 times, and the square root of 729 is 27. Then I say 1 times 27 is 27 over 3, and 27 divided by 3 is 9. So your answer for number 20 is 9. Right, now we get to the more difficult examples in this exercise. The last 5 typical exam questions. They ask 1 over 7 is equal to 7x. Solve for x. So this specific one is really easy because you simply change the 1 over 7 to 7 to the power of negative 1 is equal to 7x. And because our two base numbers are now the same, we can confidently say that x is equal to minus 1. For number 22, we've got 1 over 4 to the power of x is equal to 4. And they want the value of x. So I would start by getting rid of the fraction. If I flip the fraction to 4 over 1, it's going to change into a negative indice, right? Just like we did in the previous examples, now you're just doing the inverse operation or the opposite operation. Right, and now that our base numbers are the same, and remember there's a 1 there, we can say that minus x is equal to 1, so therefore x will be equal to negative 1. Right, for number 23, we've got 3 over 2 to the power of x is equal to 2 over 3. Again, I'm going to flip this fraction to a 2 over 3, and the minute I flip the fraction, the indice becomes a negative 1. And suddenly what happens is our base numbers are the same because there's an imaginary 1 that we do not write. So minus x is equal to 1 and x is equal to minus 1. We are not doing anything with the base numbers. We are just momentarily disregarding the base numbers just to show that that will be equal to that if the two base numbers are the same. If the base numbers are not the same, we cannot ignore these two base numbers. Okay, moving on to number 24 then. Number 24, we've got 2 over 3 to the power of x is equal to 9 over 4. Now again, please make sure these two base numbers needs to be the same, otherwise you cannot do anything with them. Right, I would, to start off with, just change this into a fractional indice. Right, I am going to take the square root of both sides of these. So I'm saying that I'm taking a square root on this side and I'm taking a square root on this side. That means that I'm going to have a 2 over 3 to a half times x on this side. And that means that if I take the root there, it's going to be 3 over 2. Now I can see that I'm moving in the right direction in terms of getting the base numbers to be the same. I need to, however, flip this fraction to be a 3 over 2. Then this becomes a minus a half x is equal to 3 over 2, basically to the power of 1, which we never write. Because our base numbers are now the same, we can momentarily disregard them, and we've got minus a half x is equal to 1. But we want to solve for x. We don't want a half of x. So I'm going to multiply both sides with a 2, right? And then I'm going to get minus x is equal to 2. And then I'm going to divide both sides with a negative. So I'm going to have x is equal to negative 2. So for number 24, x is equal to negative 2. Okay, for the last one in this exercise, we've got 16 over 25, all raised to the power of x, and this is equal to 5 over 4. Again, our aim is to get both of the base numbers the same so that we can actually solve for x. So my first step would be to flip this fraction to 25 over 16. And then the indice will change to a negative. Right? Now, the easiest way to get these to the same is either by squaring them both, or what I'm going to do in this instance, I'm going to square both sides. Right. So if I square both sides, I'm going to take the square root of both sides, okay? And I'm going to take the square root of this one and the square root of that one, which will mean that we have 5 to the over 4 to the power of negative x on this side, and on this side we have 5 over 4 but to the power of a half. So minus x is equal to a half, so x is equal to negative a half. Right, and that solves the one for 25.